This video is about Maclaurin series. 1 plus x squared plus x to the third power. We can use this formula to get 1 over 1 minus x. Let's do the reverse process of the above. If we are given a function f of x equals 1 over 1 minus x, how will you express it as a power series with infinite terms? In other words, polynomial with infinite degrees. This reverse process is called the Maclaurin series. Suppose that a function f of x has derivatives of every order near zero. The Maclaurin series is a series expansion of a function about zero as follows. The Maclaurin series for these 5 basic functions are given in the formula chart. We will use Maclaurin series formula to work out f of x equals e to the x power. Derivative for e to the x power is e to the x power. Then we will substitute the 0 for x. 1, 1, 1. We do know x to the 0 power equals 1. And 0 factorial equals 1. So we have 1 x squared over 2 factorial, x third power over 3 factorial, x fourth power over 4 factorial, x fifth power over 5 factorial. Then we do multiplication. 1 x squared over 2 factorial, x third power over 3 factorial, x fourth power over 4 factorial, x fifth power over 5 factorial. Then we get f of x equals e to the x power equals 1 plus x squared over 2 factorial plus x third power over 3 factorial plus x to the fourth power over 4 factorial plus x to the fifth power over 5 factorial. Keep going. Now I will show you how this Maclaurin series to express e to the x power. For f of x equals e to the x power, this is the graph. G of x equals 1 plus x. You could say these two graphs are so different. Then I add x squared over 2. You could say the graph is better than 1 plus x. I add one more term, x third power over 3 factorial. The two graphs are so close. Adding one more term. For this part, almost overlapped. Maclaurin series with more terms can express this function e to the x power more accurately. For the complex numbers, e to the ix power equals CIS x, which means cosine x plus I sin x. Let's substitute the I x for this x. We will get e to the I x power equals. Change every single x into ix. 1 plus ix plus ix squared over 2 factorial plus ix to the third power 3 factorial plus ix to the fourth power over 4 factorial plus ix to the fifth power over 5 factorial plus, and so on. We know I squared equals -1. I to the third power equals I times I squared equals -I. I to the fourth power equals I squared times I squared. So we get 1. We will use this rule to work out e to the ix power. 1 plus ix minus x squared over 2 factorial minus I times x to the third power over 3 factorial plus x to the fourth power over 4 factorial plus I times x to the fifth power over 5 factorial, and so on. Combine like terms, we will get 1 minus x squared over 2 factorial plus x to the fourth power over 4 factorial minus x to the sixth power over 6 factorial, and so on. Then plus x minus x to the third power over 3 factorial plus x to the fifth power over 5 factorial minus x to the seventh power over 7 factorial. Then times I. According to this formula, we do know this is a cosine x. This is a sin x. We do know cosine x is an even function, which means cosine negative x equals cosine x. That's the reason for exponents. It's even numbers. For sin x, it's an odd function. Sin negative x equals negative sin x. That's the reason Maclaurin series of sin x, the exponents are odd numbers. We do know 1 plus x squared plus x to the third power equals 1 over 1 minus x. So 1 over 1 minus x equals 1 plus x squared plus x to the third power. 1 over 1 plus x. 1 over 1 plus x you can write down 1 over 1 minus negative x. We will change every single x into negative x equals 1 minus x plus x squared minus x to the third power and so on. Both sides, let's do the integral. Integral of 1 over 1 plus x dx is the natural log of 1 plus x equals integral of this polynomial function will be x minus x squared over 2 plus x third power over 3 minus x to the fourth power over 4 plus. We still use this formula. This time, we want to figure out 1 over 1 plus x squared. 1 over 1 plus x squared, we can write down 1 over 1 minus negative x squared. Every single x changing into negative x squared equals 1 minus x squared plus x to the fourth power minus x to the sixth power plus. Both sides, we will do integral. Integral 1 over 1 plus x squared dx is arctangent x equals the integral of this polynomial function x minus x to the third power over 3 plus x to the fifth power over 5 minus x to the seventh power over 7 and so on. Now, we already figured out the Maclaurin series for these 5 basic functions. Even these formula are given in the formula chart. I still recommend you can memorize the Maclaurin series for these basic 5 functions.